Finally got the board working. Good. Okay, we're back. The board is working. Lesson 5. This one we're going to actually work on for Logan, who's out. We've got 4 rows. We're going to split it in half. So take it, just put a line right through the middle, and we're going to say that this is 1/3 was our original shaded region, and now we've got it broken into 2 pieces, 2 gray pieces. This one here, and this one here. Okay, so there's 2 pieces, so we know we've got 2 out of a total number of 6. Good. Nice. Did you write that down yet?
Yep.
If you're lagging behind, you need to pick up the pace.
So you don't want us to do 4 rows?
No, I'm just going to just break things in half for this time. Okay. Now, what this shows, Vivian, is that 1/3 is equal to 2/6. We know that's true because 1/6 plus 1/6, those 2 6s make 2/6. So we also know this, that 2 times 1/6 is 2/6. But this is actually 2 over 1. We have to watch out because in the future we're going to be putting different numbers times this, and 2 over 1 equals the number 1. 2 over 1 does not equal 1. 2 over 1 equals 2. But remember, we're going to go straight across, and just the top numbers get multiplied this time. The top number and the bottom number is still 2 over 1. So we're just multiplying 1/6 times 2. And that's going to give us 2/6. Let's try it again on the next page. Did everybody get that one written in?
Yeah.
Am I going too fast for anybody? No. Okay, I see a bunch of people still writing those, so let's get them caught up. So 1/6, we really want to see that this is the important thing, that the 1/6 and a 1/6 makes 2/6, but we can multiply. Got it. Okay, go to the next page. Let's take a look at these. They want us to do something here. We want to draw area models and decompose into these different models. So A says 1/2 becomes, we're going to draw it like this, kind of a box more. They're like, this 1/2 can become 6s. Now if I cut it in half, there's only going to be 4ths. So it looks like we have to cut it this way and this way to get 6s. 1, 2, 3, 4, 5, 6. Is that 3/6 right there? There's 1/6, 1/6, 1/6. Yes. That is a picture it shows us that yes, we can get 6s out of half, and it's going to be 3 6s. Over here I have to prove that 1/2 equals, let me see if I've got this right, 3 times 1/6. Now remember, this is 3 over 1. This isn't 3 times, we'll have a different thing in the future, but this is 3 1s. This is how many 3's we have. 3 times 1 equals 3 over 6. Just multiplying the top, the numerator on top, and not the denominator times 3, because we don't want to say 3/18. We don't want to multiply. This is going to be right straight across this way and right straight across this way. So 3 over 1 is equal to 3. 3 over 1 equals 3. 4 over 1 equals 4. Because really this is 4 divided by 1. What is 4 divided by 1? 4 divided by 1. How many times 1 is the 4? Yeah. 1 goes into 4 times. So 4 over 1 is the same way of saying 4. How many people are 9 in here? You guys 9 years old? Yeah. Are you 9 ones? 9 ones? Yes, you're 9 ones, yes. 9 tenths, huh? Let's take a look at letter B. We want to prove that 1/2, kind of a box, mark it as 1/2. We want to turn them into 8s. Well, we know that 1/2 equals a certain number of 8s. Okay, so what do we multiply by 2 to get to 8? 4. And we do the same thing at the top, times 4. We're going to get 4 8s. So 4 out of 8 are going to be shaded in. To turn it into 8s, if we cut it in half, that's only going to give us 4. Let's try cutting it in half. There's 4. Let's cut those in half again. Is that a total of 8? Okay, there's our half. And there's 1, 2, 3, 4 8s. 1/2 equals 4/8. I'm not going to do the multiplication. That just, everybody knows it.
How am I supposed to draw a straight line?
You having trouble drawing a straight line on the curve part of your book?
Yeah, I'm a crease.
Isn't that annoying?
Yeah.
Yeah,
It is very.
I'm with you. It gets better towards the end of the book
Yeah.
on that side.
Then flat.
That's flat again, yeah. Okay, just drawing pictures, guys. Not really doing anything very hard here. Okay, 1/2 equals 5/10. 5 out of 10 is half. So 1/2.
So when you're going a little too fast for remote.
Oh, okay, Rubens got. Okay, I'll just. Do you want me to move down here so you can see it? You're okay? Okay. So 1/2 equals 5/10. I'll draw a little bigger. How does 2 become 10? Times 2 times what is 10? Times 5, yep. And how does 1 times 5 equals 5? So as long as the top and bottom have been multiplied by the same number, let's see if we can show it as a box. So here's a half. Okay, this is 1/2 on this side. Now we're going to cut this into 10 pieces. So I've got to cut it into 5. 1, 2, 3, 4 lines, cut it into 5. There should be 10 pieces here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 of the 10 is equal to half. That's 5 out of 10 on that side. So the picture matches the math, I guess basically is what they want us to know. How many people is this making a little bit of sense to you? Is there any part where it's like a little confusing? Is it the multiplying top and bottom or anything like that? Not really sure. Not sure. Tyler, you're good with this stuff? Is it easy to show the cuts? Now 1/3 is our first box. This one's going to be a little different. So we're going to draw 1 out of 3. Okay, so we cut the box into thirds. We've got the first box is a third, 1/3. I'll mark it as 1/3 here. Now I want to turn it into sixes. So I'm just going to do what? Well, if I cut the 3s in half, will that be 6 of them?
Yes.
Yeah, I like that. We'll cut it right in half. So 2 6s. 1/3 is the same as those 2 6s on that side. Same fraction, haven't changed it.
Oh, I thought you.
1/3 is 2 6 because 1/3 times top and bottom, let's multiply the top and bottom by 2, equals 2 6. Since they're equal, and I haven't really changed them, if I did the same thing to the top and the bottom, I haven't changed the fraction. I've made the top and bottom equally bigger. All right? So 1 out of 2 is the same as 2 out of 6. If 2 out of 6 people, or excuse me, 1 out of 3 is the same as 2 out of 6. If 1 out of 3 people in class, 1 out of these 3 have to come with me, then if I go to 6 people, it'd be 1 of that group 2, and there'd be 2 out of all 6 people that have to come with me to be a fair fraction. The fraction will stay the same. And then 1 of those people out of 9. So somebody out of here, somebody out of here, somebody out of here, would I have to count 9 kids. If I go for 12 kids, it'd be 1 out of this group, 1 out of this group, 1 out of this group, and then 1 out of this group. So there'd be 1, 2, 3, 4 12s. It's the same fraction of each group. It's 1 out of 3. Does that seem, can you kind of grasp that concept? That's not too bad, right? All right. 1/3 is equal to 12s. We already said it was equal to 4 12s because there's the 1 out of 3, 1 out of that 3, 1 out of that 3, and 1 out of that 3 is 4 out of 12 kids. Same ratio. 4 out of 12. 1/3. There's your 1/3 equals, if I break it into 4 pieces, 1, 2, 3, there's 4 pieces. 1, 2, 3, 4, there's 4 out of 12. Same piece, right? Same size fraction. You feel good about that? Does it represent the same thing?
Yes.
Same thing? Good. And we can tell that 1 times 4 is 4 and 3 times 4 is 12. So 1/3 times 4 on the bottom and times 4 on the top equals 4 12ths. 4 12ths. So I just knocked over the mic. That's going to be loud. Sorry about that. That's going to be a little loud. Should pause it. mic is back. Sort of. No, it's got a leg missing here. Hold on. There we go. Now the mic's back. Yikes. All right. Okay. So how do you get the 4 12s? Well, you could take a 12, 1 12, times 4. Now, it's not like the top and bottom get multiplied by 4, just the top, because it's 4 over 1. You're actually multiplying it by the number 4. If I multiply the fraction 1/3 times 4, I'm actually multiplying 1/3 times 4 over 4, and that's actually the number what? 4 out of 4 is the number 1, right. 5 out of 5 is just 1, like the whole thing, right? So the number 1, does 1 equal 9 over 9? Yeah, 9 over 9 is equal to 1. Why, how come when you get 9 over 9 on a test, they give you 100 then? Well, that's a percentage. So if you're number 1, you get 100% of your test. If you can get a 1, basically, if you can get 1, that's all the percentages. It's 100%. What's this score? 4 out of 12? I bet that's not very good, is it? What's the percentage on a test there? Is it passing? No, it's less than half, right? So we know it's not even just 6 out of 12. It's 4 out of 12. I guess you'd be pretty bummed by that one, wouldn't you? That's not even half. Look, it's 1/3. It's equal to 33.3%. Bummer of a test score, isn't it? That's a bad test score. How do I know it's 33 1/3%? Just memorized it. 2/3 is equal to 66.6%. Yeah. And the last one, explain why 1/12 plus 1/12 plus 1/12 is the same as 1/4. Oh, because 1/12 times 3 equals 4/12. And that means that's actually 4 out of 12. That could also be shown as a division problem. There'd be a remainder in that one. Have you ever shown remainders as fractions yet?
No.
No? Okay. 4/12. Divide the 4 by, is 4 going to 4? Yeah. Divide this by 4. Can we reduce it down? If we can multiply it to get it bigger, can we divide it to get it back down?
Yeah.
4 divided by 4 is?
1.
1. 12 divided by 4 is?
3.
3. Oh, wait a minute. I messed up, didn't I?
Yeah. Yeah.
I want to show it as 1/4.
Yeah.
Oh, I put 4/12. It's actually 3/12. Okay, so 3/12. Can we divide the top and bottom? What's the number that divides 3 and also divides 12? Angelina? Okay. 3. Okay. So 3 divided by 3 equals 1, and 12 divided by 3 equals 4. Okay, so if I had 4/12 up here, I could have 1/3. If I have 3/12, I'm equal to 1/4. Can we get these smaller than 1/4 and 1/3? Or are those in the lowest terms we can divide them down into? Is that the lowest we can divide them down? Yeah, I don't think there's anything. Once you get 1 on the top, you know the fraction is down in its lowest terms. We can't divide anything.
Now we have to explain.
How about 3/5? Is that in lowest terms? Are there any numbers we can divide the top and bottom of that one? We could divide 3 by 3 and 5 by... No, that wouldn't work, is it? That one's also in the lowest terms. What if I multiply the top by 3 and the bottom by 3? Oh, that would be 9/15. That would not be considered lowest terms because it's actually been puffed up by a multiplication of the original fraction called 3/5. This is the smallest, like you would call it 3/5, is equal to 9/15. But 9/15 is not the one that's reduced down to the lowest terms. Does that make sense to everybody? The original drawing of 3 out of 5. Okay, so if you got 5 pieces, let's go 1, 2, 3, 4. The original 3 out of 5 has been cut into 9/15 by dividing it this way again. So there's 15 pieces, but the original was 3 out of 5. But I'm showing now 9/15. Yes, Colin.
You can multiply fractions like up until infinity.
Right. You can. Yep. You could do fractions. They can get as big as you want because we can always make a fraction out of that's the same kind of fraction. Let's say let's say we want to play an unfair game of kickball.
No.
And we always want the fraction of 9 people on one team and 10 people on the other. Okay? It's a relationship of 9 to 10. But if somebody joins the game, let's say if we got a 9 to 10, if somebody joins this side, they have to join the other side, right? So we get these bigger groups, so it's always like the same ratio. If I add 90, I'd have to have 100 on that side. It's the same ratio. 90 people to 100. As long as I multiply the top by a number. Is 10 to 11 the same as... Oops, sorry. Let me back up here. Is 9 to 10 the same as... And this is a question now. Is 9 to 10 the same as 10 out of 11? Do you guys remember last year from 3rd grade how to tell if two fractions were the same thing? Did you guys cross multiply to just find out? How many people remember that? You can find out. Okay, so is this number and this number, are they the same fraction?
No.
In this case, no. 10 times 10 equals 100. 9 times 11 is 99. They're not the same. Just because you add a number to the top and bottom doesn't keep the ratio the same.
So you can't like add the fractions, so it can't be like 9 plus 1 or 10 plus 1.
Right, you have to actually use multiplication where you use the same numbers over again. Or you could reduce it down to 3, back down to, going back down to 3/5. No, you can't do. You can't reduce this one down. 9/10 is in the lowest terms. There's nothing to break that one down, so you can't even break it down. But you can multiply it times 2 on the top, 2 on the bottom. Then you'd have the same fraction. You'd have 18. Yeah, is 18/20ths, and you could check and say, is that equivalent? And then go down to the 9/10 and you say, wait a minute, is that the same as this times this? That's 180. Is this 180?
Yes.
Yep. 2 times 9 is 18 plus a 0 is 180. So that's the same fraction. Equivalence.
So that equals 1 right there.
So this equals 1. Yep. Mm-hmm. Kind of wild, isn't
Such
it?
a big number.
Yeah, and this does not equal 1. Okay. Can you think of 2 other? What's another equivalent fraction you guys remember to see from today's math lesson? Was there 2 that were equal? Yeah.
3/4 and 3/4 and 6/8.
And 6/8. So if you wanted to check real quick and say, are they equivalent? You can cross multiply those and you should get the same answer. 4 times 6 equals 24.
Yeah.
3 times 8, 24. You got it. Those are exactly the same fraction. They're equivalent. Okay. Pretty cool. Yeah.
And another way to find an equivalent fraction is to add that fraction to itself. The denominator and everything.
So if you add 3/4 to 3/4,
You would get 6/8.
okay, when you add fractions, it's a little different, guys. We have to keep the denominators. It's still going to be fourths. There's just going to be a lot more fourths. There's going to be 6/4. We're actually going to go past the number 1. If you add a lot of fourths together, we're actually bigger than the number 1 now. This is equal to 2/4 and 4/4. So it's actually equal to 1 and 2/4. So adding fractions and multiplying them are different. They do a different thing.